Welcome everyone to the next experiment, or this really isn't much of an experiment, it's more of a modeling activity, but welcome nonetheless to Kayleigh's weather workshop. So I posted yesterday that you needed some Oreos or any sort of cream-filled cookie. HEB came through for me this time with these twisters. And your other supplies, you'll need some paper towels, a Sharpie to label said paper towels, a butter knife, a plastic butter knife works as well, and that's about it. That's all you need for this experiment. We're gonna be talking about, I know, what do cookies have to do with weather? We're gonna be talking about winter precipitation. Crazy, right? But we're gonna be modeling what the atmosphere has to look like in order to support different types of winter precipitation, and we're doing so with our Oreos, or whatever your cream-filled cookie of choice will be. So here's the deal. We had a winter storm last week, and I know for myself at least, leading up to it, we were talking about wintry mix, sleet, freezing rain, snow, all the different types, and we were saying it was very temperature dependent. And I know that kind of confuses a lot of people because we know obviously it has to be cold to support most of these, rain being the odd one out. But where does that temperature really depend? And it's all the way from the bottom of the atmosphere here in the surface all the way to the top. So we're going to model using our cookies here, and we're going to start with the easiest one, or one of the easiest ones, in my opinion, is snow. So when you separate your cookies, you're going to take the cream out of the center, and they're not full discs, and that is okay. Science isn't perfect all the time. We're going to make do. So any of the icing, you're going to label that paper towel below 32 degrees. So that's your layer of atmosphere that is below freezing. So this is very, very cold layers of air. And then the cookie part, you're going to label that above 32 degrees. This is a warmer layer of the atmosphere that if something were to fall through, it's probably going to be on the liquid side, or it'll start to melt. So we've separated our Oreos, we separated our cookies. We're going to start with snow. Let me move some of this out of the way. Here we go, snow. We know it has to be cold to support snow, and it has to be cold all the way from the top to the bottom. So take your first layer of icing, and I know it's probably gonna fall apart. Mine are, and that's okay. So there's your surface. We know that we have to have a cold surface in order for snow to stick. That's how we get those fun snow days, because without the surface being cold, you're not gonna get any of that winter precipitation to stick to the ground. So the next layer up in the atmosphere, it's also going to have to be, you guessed it, cold. You're gonna layer another layer of icing on top of it. And guess what? The next layer, cold. Snow starts as ice and it stays ice through the entire way it falls. See, look, my atmosphere layer just cracked in half. That's okay. We squish it together. There we go. And then our last layer, obviously, is cold. So this is my favorite model here because it is simply all icing. Now the next easiest bit is going to be rain. So rain, much like snow, starts as, I just dropped a cookie and that's a-okay. So rain starts as ice. I know you may be thinking, well, but it's water when it hits the ground. Well, that is because it falls through several layers in the atmosphere that are above 32 degrees. So we're gonna take about 3 or 4 cookies, and then we're gonna layer one little pad of icing on top. So when rain starts in the atmosphere, again, it starts in the cloud as ice, and as it falls, that ice melts, 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 and it falls as water. Now comes the trickier types of winter precipitation. We will start with sleet. So sleet, it's gonna look a lot like snow. Again, most precipitation starts as ice. So you're gonna need one little pad of icing with you here. But once that falls, we're going to build from the top down. This will be a little confusing, but it's okay. So here we go. Here's your ice, your one pad of icing. And we're gonna put that on top of a layer of cookie. So this is at the top of the atmosphere. Sleet starts as that ice crystal, but then it's gonna fall through something that meteorologists call a warm nose. So a warm nose is going to be a thin layer of the atmosphere that's above 32 degrees. So we will see that snow or that ice melt just a little bit, and then the rest of the atmosphere is going to be cold, much like snow, because we have to have it cold to stick to the surface and for that to refreeze. Because once that sleet starts to melt, we have to refreeze it a little bit. So we'll put about 3 layers here of our atmosphere. Not full layers because my icing keeps falling apart, but that's okay. And then we'll put that on top. So again, from the top down, sleet starts as ice, goes through that warm nose, melts just a little bit, but then goes through the rest of the atmosphere, which is below freezing, and that allows for that ice crystal to form, and we get sleet pellets. And Graupel is similar, but we'll do that for another day. Stay tuned for another weather workshop, and we'll talk about Graupel. And here's our last one, freezing rain. So freezing rain, we're gonna build from the bottom up. Freezing rain is obviously rain. So the setup is going to be similar to rain in the fact that it'll start above freezing. So we'll need some more icing pads. I'm down to my bits that fell apart, but that is okay. We'll just smush it into a little pad of icing. But we're gonna start from the bottom up. So for freezing rain, we need the temperature, the surface, to be below freezing. The way freezing rain works is it falls as rain, but when it hits something that is cold or below freezing or just at it, it freezes on contact with that object. So here's our freezing surface. Here is a cold car last week that was sitting outside before we started seeing that rain fall. And then here comes the rain. Again, rain is that liquid water, it's that liquid precipitation. So there's the warm layer of atmosphere. We'll give it one more layer of warm atmosphere here with another cookie. And then, like I said, most precipitation starts its life as ice. So here is that ice that melts. So just one more time to recap that freezing rain setup. Again, we start as ice. We go through a larger and deeper warm nose than we saw for sleet, because this allows that ice to completely melt into a liquid raindrop. And then we can see that really thin layer of icing at the bottom. That's our freezing surface, and that's how we see that rain freeze on contact with those colder surfaces. And that's pretty much it. And as we can see, it's very temperature dependent, like we talked about in all of our forecast and leading up to it last week. And it's all dependent on where that freezing line sets up, where in the atmosphere we start to see the temperature be above or below 32 degrees. And where that sets up depends on what we see here, and that's why 1 degree difference and maybe just 1 mile away from you, you're seeing freezing rain versus seeing sleet. Winter precipitation is a very hard thing to forecast, but I think this is a pretty tasty way to learn how the atmosphere needs to be set up for it. So enjoy your models here, and then enjoy a quick snack of your leftovers after. And I'll see you guys in not next week, but the week after for our next episode of Kayleigh's Weather Workshop. Again, let me know in the comments if you have any sort of weather questions that you would like to see answered, or any sort of experiments that you would like to see demonstrated here on Kayleigh's Weather Workshop. I'll see you guys in a couple weeks. Enjoy your tasty snack. Bye.